Welcome to Programming in Modern C++. We are in week 6 and we are now going to discuss module 30. In the last module, we started designing for a staff salary problem and worked out a C solution. We would like to continue on that design to refine it with repeated set of observations of what is working well in the design and what is not, to get to a good solution from a starting one in C that we have already made. So, it is more a design journey. You are not going to learn anything new for the language, but you are going to learn very useful thing in terms of how to do the design, how to refine, and what are the pros and cons of doing designs in a various different ways. So, I suggest that you go through this module repeatedly to understand the basic design principles in C++. This is the module outline available on your left always. So, before I start on this, let us just quickly recap on the C solution. Here is a recap of the problem. The organization needs to process salary. It has engineering division with engineers and managers. They have different logic for their salary processing. In future, directors may be added. The directors salary processing would also be different from all these, and further in future there may be new divisions and we need an extensible design. So, based on this we started by asking different questions of how to model the object, how to initialize, how to make a collection of stuff, how to represent the processing functions, how to invoke them and so on, the common questions, and based on the answers we made a design in C. And here is a summary of the advantages and disadvantages of the design. Obviously, the main disadvantages are as we have noted. One is in terms of the object design, there is no encapsulation, duplication of fields and so on. And second is primarily in terms of management of different types of objects, which are different, but related in a strong way. I mean, engineer, manager, director all are related in a strong way. So, we needed to do an explicit management through an E-type tag, and that makes the addition of new type of stuff difficult, that makes it error prone. There is a function switch and all of that difficulties. We are not being able to use function pointers because of non-uniformity of processing function signature and so on. So, based on all this, the basic recommendation that we got ourselves is we will use classes for encapsulation on a hierarchy. Right? So, we are now going to get into that part of the design C++ solutions based on the earlier advantages and disadvantages. So, we asked the same set of questions. The answers of course are different. Now, we formally have represented the is a relationship. Every manager is an engineer, we know. So, what we decide is to use non-polymorphic class hierarchy. That is the simplest form of inheritance hierarchy that we can have. Initialization, release, constructor, destructor, obvious choice. Now, we have array of base class pointers. We do not need the union anymore, because there is a specialization. So, I can have a base class pointer of engineer type which can represent either an engineer or a manager. Naturally, salary processing moves to member function, but dispatch in terms of which processing function to call will still remain under function switch. Right. So, this is our design refinement criteria. So, based on this, let us write the code. Easy. We have the staff type here, like the enum. We have now made the struct engineer as a class. So, what we are able to do is we are putting the string name as well as the struct type, employee type as fields in this protected data. Then we have the constructor, we have a method to get the employee type, because we will need to make decisions based on that, and then we have a process salary. The same thing we do for managers, which is a specialization from engineers. So, these data fields are not, data members are no more required to be specified in the manager, they are inherited. So, refactoring of data is automatically happening through the inheritance. We have the manager constructor, the processing salary, because that will be different. This is overridden in the manager class, and getting e type function I do not need to override, because it is going to be the same for the engineer as well as the manager. So, certainly you can see that the design is getting simpler, cleaner. With that, let us write the main function. These are the managers and engineers that I create. Finally, I need an aggregate, the staff aggregate, where we put the pointers of all these objects. It is an aggregate of engineer star, engineer pointer, because that is the base class. Right. So, for say ampersand M1 or ampersand M2, M1, M2 are manager objects. So, here this will work through the upcast along the hierarchy. So, with this array, we will be able to maintain all my processing, all the stuff here. This is a for loop. Instead of hard coding, we are using the size of this array to find out how many to be processed. Then how do I process? I have to know which type of employee exists at a certain point in your staff ith employee. So, on this pointer we do get type. Now, get type is, there is only one function which is implemented at the root. So, it will get the employee type. In T, like before, I check if it is an engineer. If it is an engineer, we invoke process salary, simple. The engineer class has a process salary, so I invoke that function. If not, then we check if it is a manager. Now, if it is a manager, then what do I need to do? I need to invoke the process salary for the manager class, but this pointer is of engineer type. Right? So, I need to change this pointer to manager type. What am I doing? Can you identify what am I doing? I have a generalized class pointer engineer, and I am making that into manager pointer. So, I am actually doing a C style casting which is a downcast, but it must be okay there, because that is how I have set this tag. So, if the tag is manager and if I cast it to manager star, it should be fine. So, now this pointer after casting, this pointer, the pointer after casting is a manager type pointer. So, if I invoke, it will invoke the process salary of the manager class. Right. So, it would be fine, otherwise I do invalid. Right. So, I made a substantial change, and you can see there are a lot of things that have got simplified, that have got structured, organized, but still there are lot to go. Now, before discussing that, let us try to add the directed type here. So, if we add the directed type, really none of these questions will have a different answer. So, we will just have to go and do it in the code. Right. So, let us do it. I need to add the tag type. Nothing changes in the engineer and the manager, but I just specialize from the manager to create a director, have its constructor, have its process salary, implement. So, the addition still needs care, but that has become substantially less now. Let us look at the situation in the main function. In the main function, we still collect all these employees in an array of pointers, do everything else in the same way, and we have a type switch. Now, I have to add this part. If T is director, then now the cast will be again another downcast. I am doing one risky thing after the other. I have to cast it to director star, because now I have a director and invoke the process salary for a director object, different from the engineer and manager. Right. But it is not yet totally clean, but certainly it is cleaner than what we had earlier. So, let us take a stock. What all advantages have we got by doing this change? First is data is encapsulated. That is a first object oriented principle is satisfied. Data is encapsulated. Hierarchy has factored the common data members, like the employee type and the name of the employee and so on whatever common data members are there between the employees, like their employee code, address, date of birth, date of joining, all of that will be there, will similarly get factored into the base class. Constructor destructors to manage lifetime, which is a clean solution in C++, we know. Struct type, this struct specific member functions that we had, they have been struct specific functions that we had, they have been made into member functions. So, what is the big advantage in that? The big advantage in that is, earlier all these functions were having different name: salary processing engineer, salary processing manager, salary processing director. Now, all of them are salary processing. Depending on which class they belong to as a member, they have different implementation, they are overridden. So, now we have engineer : salary processing, process salary, manager : process salary, director : process salary, and so on. That becomes a lot more nice and uniform in terms of the design through this overriding mechanism. I do not need the union anymore, because what I am replacing the union with, one is E type is subsumed in the class, is a part of the class itself. So, it is inside. So, the class itself remembers, and what am I substituting union for? I am substituting union by upcast. I have an array of pointers where the upcast combines everything in terms of base pointer, base class pointer, but I still can dig into that object and get the E type to decide which type of object it is. So, the code reuse, the amount of code reuse has substantially increased, it is directly evidenced. But it it still continues with the disadvantage, the type of the object is still explicitly managed by E-type, right. I am putting an E-type. When I had to add the director, I had to add a new type to the enum, I had to add a specific case, I had to do a case specific downcast, very risky. If I make any mistake, that is the application programmer has cast to right type of call, right type to call the process salary. So, all risky things, lot of risky things are still remaining. So, what is the recommendation we gain? We have gotten these advantages by the mere use of C++ classes and by the use of hierarchy, but we have so far kept that hierarchy non-polymorphic. So, let us make it a polymorphic hierarchy with dynamic dispatch and see what advantages we gain over the design that we have done so far. So, what we have in terms of the hierarchy is the same. The change is in the first answer to the first question, how to represent these objects. We say in a polymorphic class hierarchy, right. Rest of this is same, array of base class pointers is same, member function is same. As I do polymorphic class hierarchy, naturally my dispatch mechanism or the way to call object specific processing function now do not need a function switch. It can use function pointers in the form of virtual functions, right. So, these are the two main differences after the analysis of disadvantages that we have seen, and we are going to try this in the next iteration of the design, next refinement of the design. Okay. So, now this entire E-type stuff is gone. We have the hierarchy, manager is an engineer, director is a manager, every constructors, processing functions, everything. The polymorphism comes through making the process salary virtual in the base class, root class engineer. So, as such the class part of the design is more or less similar, except for the E-type is erased, and this is process salary function, member function is virtualized. Let us look at the main code. I still need the collection to be built, of course. The for loop, this does not change, but look at this. What has happened to that type switch? If t is equal to ER, do this. If t is equal to MGR, do this. If t is equal to DIR, do this. You have 20 types, long chain or switch. All that is replaced by only one call. How? Because now we have a polymorphic hierarchy where process salary is a virtual function in the base class engineer of which the pointer type I have got. So, this pointer has the current stuff I pointer has a static type which is engineer, but its dynamic type will keep on changing as it traverses. For the first object it is engineer, so it will invoke the process salary for engineer. For the second object it is manager, so it will invoke the process salary for manager. Third again manager, fourth again engineer, fifth engineer, sixth is director. So, it will invoke process salary for the director. So, you can see how drastically things have got simplified, compacted, and the kind of there is a step jump in terms of the quality of design that we have got with this refinement. We have to assess ourselves, for further refinement. Naturally, in terms of advantages, what gets added are two things. One is a couple of things. One is polymorphic hierarchy, which is remove the explicit use of E type. Application code for independent type are not needed, virtual function takes care of it, substantial code reuse and code shortening. Does it solve all the problem? Unfortunately, no. You will still have to remember that as soon as you want to add a new hierarchy, new employee type that is not a part of this hierarchy, you will have to do a lot of things. So, what is that we are missing out? If you look into the entire hierarchy is of concrete classes, which says that everything that we have is what exists, but that does not keep a scope for the future, where we open the gates for whatever can come in future. For that we need an abstraction, and for that we need an abstract base class kind of an employee at the root, so that we can anytime go and add classes wherever we need them to be added. Let me explain this little bit more with a diagram. So, earlier we had only this part. Now, we add an abstract base class, and cells executive which we want to add is naturally not on the engineering cadre. So, it goes in a different way. So, what changes to our answer is polymorphic class hierarchy with an abstract base class employee, which was not there. The moment you have abstract base class, or the moment you have a class which can be extended in any way at the root, you do not know how to process the salary of that employee, because it is just a concept, it is not a physical employee, just a concept. So, which means that your processing function will need to become purely virtual at the employee, everything else remain the same. Right? We are just opening up the polymorphic hierarchy for easy extension and additions in future. So, we have this base class created, employee. We continue to refactor. We know whatever the employee is going to have name, address, date of birth, date of joining and all that. We can put all of that refactored into the base class. This is the key point, that we provide the process salary here as a pure virtual function, because we do not know what is the logic of processing the salary of this employee, who by himself is an abstract concept, herself is an abstract concept. Keeping to our learning from the last module, we make the destructor of this employee class virtual, right, so that we do not have any slicing. So, this is your base class design. Then rest of it is extremely modular in the way it goes along the hierarchy that you have. So, engineer is an employee, manager is an engineer, director is a manager, sales executive is an employee, and you have constructor, you have process salary overridden in every case to be able to process these different cases. The processing code, it now has seamlessly been able to add a sales executive, and note, very importantly, this code does not need to change, no change in that code. Your hierarchy has extended, and you are making this call from the abstract base class pointer employee. which will get dispatched to either an engineer or a manager or a sales executive or a director, as the case would be, and you do not need any changes there. Right. Beautiful, is not it? Assessment again, there is always scope for refinement possibly. So, what we see is advantages remain the same. We have added flexibility by adding this abstract base class. We have almost maximum code reuse, no code is being duplicated, replicated anywhere, but we still have a disadvantage. The disadvantage is we still need to maintain the aggregate of the employees through an array. If I can just go back to that previous, yes, this is what I mean. I have to maintain this array, right. So, if there is an object instance, employee instance created, which is not added to this array, we will have problem. If an instance is added twice, you can understand what will happen. Two salaries will be paid to the same employee. So, this remains a pretty vulnerable part of the design, and when you have thousands of employees, would you think of doing this hard coding in your code? Every time an employee joins, he will go and change the code and add that, not possible, right. So, this needs to be cleaned up, that is the basic. So, what we say is let us do this let us look at it in a little different way. We are saying that these are the objects created and then the application is adding them. Why? When the object is getting created, it could add itself to the collection. It could add itself to the collection, right. If I need to do that, I need an active collection. I need just not an array, but a data structure where I can just invoke a method and get myself added, collected, right. So, my recommendation, our recommendation is we will use vector as a collection and insert staff as they are created to get rid of this disadvantage. Refined design. So, vector included. Now, in the abstract base class, we introduce a collection. We make collection, we will move that from the application code to the class hierarchy code and make vector of employee pointers a member in the employee class. Obviously, this collection will be a unique one. Therefore, this is static, right. This is next. I need a way to add this. So, we provide a method add staff, which takes this vector and pushes the current employee pointer that will add the staff to the collection. Right. So, now what changes is when I am doing class engineer, which is an employee, I need to add staff, and this because in the constructor it is now constructed. So, I add myself to this staff collection. Similarly, I do that for class executive add staff. Remember, this is where remember the structure, this is your employee, this is your engineer, this is your sales executive, this is your manager, this is your director, right. So, this add stuff is needed in these classes, which are after the abstract base class, which are the root of the concrete classes. Naturally, you do not need it here, because to construct a manager, you will obviously construct an engineer, and object as a base and add stuff will happen, right. So, with this I have the advantage that I will not need to manage the collection anymore. All that will happen automatically as and when objects are created, they will get added to this collection. So, all that I need to do is go over this collection. There is a small nuance which I would like to mention here. For example, here in creating the name, I have done it in the body, not in the initializer list. Normally, we have said that always do it in the initializer list like this. Right. Please note that that is not going to work in this case. The reason is simple, is name is inherited from the employee class, which is abstract base class. So, engineer does not have directly a name field, it will come from that abstract base class. But being an abstract base class, it will never get constructed. Being an abstract base class, it will never get constructed. So, engineer constructor cannot refer to that. So, we have to go through an empty initializer here, get the default object constructed and then actually set this name field, right. So, this is a small understanding in terms of the object layout that you need to keep. So, having done this, now we have this global vector, so which is employee colon staff. So, I need to define that in the global space. I do that because it is a static, and I am just creating the objects. I am no more having to add them, they are getting automatically added. Then finally, I have to go over this vector. So, what I do is the standard vector mechanism. I will construct a constant iterator. Why constant? Because I do not expect to change any employee object, just process that. So, and do a start, go up to begin to plus plus, and on every item I will call process salary. Absolutely compacted. Now, it does not depend, this part of the main application function does not depend on the classes, instances or anything, they are just generic, and I can freely keep on adding classes as I want, and I have everything that I actually looking for. Data is fully encapsulated, flexible polymorphic hierarchy, where free addition of any class is possible at any stage of the hierarchy. Application code is independent of types in the system, virtual functions managing all polymorphic dispatch, maximum code reuse, short, simple, collection of stuff encapsulated for creation, vector and iteration increases the efficiency and efficacy of the solution, no particular disadvantage as such. So, we can enjoy the solution. So, this was to summarize, this is an exercise. I mean, I did not want to just ask the problem and give you the solution, but I made this walkthrough to make you realize that you cannot, given a problem, you cannot jump to the best solution in one stage. It is never possible. You will have to go through stages of refinement. Now, some of you may be grasping it well, so that you start with the non-polymorphic hierarchy as a first design, skipping the C part, structure based design. Some of you may be even more mature to start with the polymorphic hierarchy. It depends. There could be other ways of doing that, but what you will have to remember is you always need to start at an initial solution and ask design questions repeatedly to see how it can be improved. Keep on doing this till you meet all your design objectives. Thank you very much. With this, I conclude this module. Thank you for your attention, and we also conclude the discussions for this week, which has been primarily your exposure to polymorphism, both in terms of the language features as well as the design practices, which will be the core of take back from the object oriented side of design in C++. Thank you very much. See you again in the next module.